Let's open the lesson. There's a nice video at the top, not a lot of text. There are several worked examples. Some learn by doing activities with hints. And at the bottom, a did I get this to see if I understand. Wow, there's a lot to do here. I'll scroll to the first learn by doing activity. I'm supposed to calculate how many moles are in a sample consisting of 1.22 grams of sodium chloride. I'm asked first for the unit and substance that belong in the denominator of this fraction. In order to do this conversion, I need to use dimensional analysis. I'm being asked, what should I put in the denominator? I'm told to put both the symbol and the chemical formula. I've learned about dimensional analysis already, so I know that the denominator's unit should cancel on both sides of the equation. This part is pretty straightforward. I can just put in G in sodium chloride. Seems like the right answer. Let's find out. Oh, correct. Great. I'm getting some immediate feedback that tells me that I got the right answer and it explains a little bit about why. Now, I need to think about the numerator. Again, I'm supposed to include both the symbol and the formula. Well, we're just converting from grams of sodium chloride to moles of sodium chloride. So I'm going to put mole sodium chloride. Let's see what happens. Great, again, I get this positive feedback. I'm getting confidence that I'm on the right track. I'm going to continue to the next step. The answers I just gave are shown here, which helps. I don't have to take notes. I know that grams of sodium chloride on both sides of the equation will cancel, leaving moles of sodium chloride. That's what I'm solving for. But now, I need to figure out what numbers to put in here to do the calculation. First, I need to figure out what value goes with grams of sodium chloride in the denominator. I'm not entirely sure what I should do here. I see a hint bubble. Let's pop up a hint. It tells me that the molar mass of sodium chloride goes with the gram sodium chloride unit. I guess I want to put in the molar mass of sodium chloride? I think I need to check the periodic table. I have one open in another tab. Checking the sodium. I see right next to it is the number 11. And for chlorine, I see number 17. So I'm gonna add this up. This is 28. So I guess the answer here is 28. Let's try that. That's wrong. Okay, so let's ask for another hint. It says calculate the molar masses of sodium chloride by adding the atomic mass of sodium and atomic mass of chlorine. Isn't that what I did? Oh, the numbers I looked up weren't the atomic masses. They were the atomic numbers. I make that mistake all the time. The periodic table says the atomic mass of sodium is 22.99, and the atomic mass of chlorine is 35.45. So let me reset here. I'll put in 58.44. Let me try that. Great, got it right. Now I'm asked what value goes with moles of sodium chloride in the numerator. So what number goes up there? Well, why would there be any number? Isn't that what I'm trying to calculate? I'm a little confused. Let's ask for another hint. 58.44 grams of sodium chloride is equal to 1 mole of sodium chloride. Oh, right. So 1 mole of sodium chloride weighs 58.44 grams. So I think I must go up 1 here. Let's try that. That's right. Great. That hint got me right to it. Awesome. I can continue. It set up my equation with my answers. Now I know I just have to calculate this, like in the worked examples that I saw above. I'm going to do this off screen with my calculator. 1.22 divided by 58.44, that would be 0.02. That's right, great. I think I kind of get what's going on here. I went through this whole example and I needed a little bit of help. And I got one thing wrong, but it helped me with my mistake and corrected me. This is great. But I still feel a little shaky on these mole calculations. Let's look at that video I skipped before. Maybe it can help. I can search for words in the video. I can also search the transcript and download it. Nice. Let's watch a little bit of this.
I love fries. Chemistry and love have something in common. In both cases, it's what's on the inside that counts.
This is fun. I definitely want to check it all out later. But right now, let's see if I can find a mole calculation example.
On the inside. When we say the composition of substances, we're talking about the type, ratio, and arrangement. To calculate the moles of sodium chloride in our sample, we just need to divide by its molar mass. So we have 10.8 grams sodium chloride times 1 mole.
It's great to see a live worked example. I usually have to hunt around YouTube to find this kind of thing.
Giving us 0.185 moles sodium chloride. Similarly, we can calculate the moles of potassium chloride.
But I'm confused. In some places it says molar mass of sodium chloride, but in other places it says formula mass. Are they the same thing? Well, I can ask a question right here. Not in a different system like Piazza or the Canvas discussion board. I don't have to take screenshots or explain where I am in the course. I can post right on the page. Let's see how soon someone will answer.
I see some discussion activity in the course. It looks like Darnell has a question and Lynn has offered a response. I better go take a look. If I click on Darnell's post in the discussion overview, it takes me right to the page he's on. That's cool. In every other discussion system I've seen, I have to spend time figuring out what part of the course the student is posting about. In Real Chem, I see right away. So I've got all the context I need to interpret Darnell's question. Lynn has anonymously responded within this thread. She must be unsure of her answer. I better answer them. Great question, Darnell. Formula mass is often used for ionic compounds. Molar mass is used for molecular compounds. Most chemists see student response do not make this distinction. We tend to use molar mass for all compounds. Hope this helps. I will also answer Lynn. Nice job. Say response below for a more detailed explanation on why we do this.